We cannot see the chat if we joined after you put it in.
Okay, well, I will read it to you.
Okay,
And so I'm going to go there now. I was just waiting for the recording notification. So I'm going to go to the chat, to the conversation. And this is the Tuesday, Thursday class. The comprehensive final is on Tuesday, 5/4, from 12:30 p.m. to 2:30 p.m. Now, I'm willing to go from 12 to 3, but no more than that, because I have 6 total classes and I have to make sure I'm supporting them one at a time, because if I don't, then it becomes, okay, this class is using this proctoring software and it's a different class, and then because I have a couple of classes that are using Proctored U because they don't have Alex versions of them, and so it gets too confusing for me and helping the students, and I want to make sure I can help the students in a timely fashion, especially when it comes to testing. What I will do though is, since I have shared my screen, I am going to go to the NWAC final exam schedule, which is right here. Our class meets on Tuesdays and Thursdays. So the first page of this is the classes that meet Monday, Wednesday, or Monday, Wednesday, Friday. The second page are those classes that meet on Tuesday or Thursday, or maybe just Tuesday and maybe just Thursday. So that's where we fall. Our class start time is at 12 p.m. And so that means that our final is from 12:30 p.m. to 2:30 p.m. T for Tuesday over here, 5/4 is the date. So that's how I read this schedule. And I got to it by just putting NWAC and then schedule in up here. That's where I put it, and then it pulled it right up. I mean, it had the, I think it was the first one, and I clicked on the link, and that's how I got to this document. So Alejandro, if you're trying to put a schedule together, I don't know if you have any other finals during final exam week except for this one, but that's where you can go to see the final exam schedule. Any questions?
4 of my classes are during final exam week. I think if there is a conflict between your class and another class, how do I go about doing that? Do I talk to the other professor? Do I talk to you? I still don't know when she's gonna decide, because she told us that
there should not be a conflict. That's the reason for the schedule.
Okay, all right. Just making sure.
If there's a conflict, it's not on this class's side, because I'm having the final right when it says according to the schedule. And that's the reason why NWAC wants us to do that, so that students don't have conflicts. However, I'm not sure that there's 100% compliance with all the professors at the college, is what I want to say.
Okay, I'll get with her.
Yeah, okay. Okay, so yeah, but you can talk to her about it. If it becomes really a problem, you can you can come talk to me, or contact me. But I would prefer if you took it at the stated time. Okay.
Awesome.
So the other item I want to mention is I am going to make sure that the final exam review assignments are open today, if they're not already. There are 2 final exam review assignments. One is worth 5% credit, which is like 30 course points, and the other is worth 5% bonus points, which is another 30 points, approximately 30 points credit. So together, those are worth 60 course points. And every question on the final comes from one of those 2 assignments, either from the final exam review assignment for credit or the final exam review assignment for bonus points. And they're probably, honestly, I don't know how many questions come from each assignment. So there are several questions at least that come from each one of those assignments. So it's important to do them both. 60 course points can make the difference for sure in passing the final or not. If you don't pass the final, those extra points though can help make up for not passing the final. So I will make sure those are open today. I see that Matthew has joined us, so I'm going to put Matthew down for attendance. And let me just check my second page here. And Maddie joined us as well. I'm going to put Maddie down for attendance. Okay. So I think we're pretty well caught up and ready to go here. Anybody have any other questions before we get started? Okay. Yes, Matthew.
So when we have our grades for the exam we took on Tuesday.
Yes, no, because I have 6 classes and I got up in the middle of the night last night and I graded one of the classes, a big class of students who took an online exam. Yeah, it's going to take a few days. I've got a survey of calculus class ahead of you that took their test last week. And so I've got to do theirs first. And then I will then do yours. So ever how long that takes, but I've got meetings and other items of business that I need to take care of as well. So it takes a while because full-time faculty have lots of other things to do besides teaching as well. They're required to do. So I'll let you know just as soon as I have them graded.
One more question.
Sure.
Whenever we finish the 2 assignments for the finals, can we still work on the assignments from the other ones in Alex?
You still will need to do the the objectives, yes.
Okay.
Yes,
that's it.
Because the objectives are in the artificial intelligence portion of Alex, and these final exam review assignments are in the portion that I create. So they won't interfere with each other.
Okay.
So any other questions? So let's go down to my desktop and we want to continue looking at polynomials and zeros. We've got 3 topics that I want to do there, and then we want to start looking at rational functions today. So I'm going to go down to my desktop right here, and I took some of these questions. I decided not to do them, and so the first question I want to do starts on page number 3 here. Right here. So these first 3 topics that we are going to do today, we are either going to find zeros, Z-E-R-Os, or we are going to find the factors, the linear factors. In order to sometimes find linear factors, though, we need to find Z-E-R-Os. So we're going to look at those 3 topics, and for a couple of them, we're going to see 2 different questions in the same topic. So let's get started with this one. Using the rational zeros theorem to find all zeros of a polynomial. How do we know how many zeros we have? What do we look at to tell how many zeros, that is ZEROs, we have to account for?
The exponent.
Which exponent?
The bigger one, so it's 4x cubed.
So the exponent would be?
4x cubed.
So the exponent's just what's in the power, and that is?
3. Yes.
So that means we've got to account for 3 zeros here. So you want to look at your highest exponent, and that tells us how many zeros we need to account for. So in this case, that is 3. Now, in theory, it's possible to have a 0 of multiplicity too, and we're going to see that today as well. So that's great. Thank you for answering those questions. So that's great. So if you notice, we read the problem, the function below has at least one rational 0. Use this fact to find all zeros of the polynomial. We're not given a 0 to start with in this problem. So I'm guessing what I want to ask you is, I did not require graphing calculators this semester for this class because I wanted to be mindful in this pandemic that, you know, households don't necessarily have as much income as they did prior to the pandemic. So I did not want to require students to go out and buy or order online a graphing calculator that cost at least $130. So a good way to do this problem is to use the graphing calculator. However, you may not have one. So are there any students in this class who do not have a graphing calculator, is what I want to ask. Or do you all have one? Can you let me know by raising your hands how many students have graphing calculators? So can you just leave your hands up for a little bit? How many of you don't? Can you put your hands down, those that raised them up? How many of you don't have graphing calculators? Let me see. I'm going to go into it. Okay, so Matthew, you do not have a graphing calculator, is that correct?
Yeah, I don't.
Okay, that's good. It's fine. I'm going to take a look there. So let's talk about how we find possible rational zeros when you don't have a graphing calculator. And then we'll look at the graphing calculator as well. So when you don't have a graphing calculator, this is how you want to begin this problem. You want to look for possible rational zeros. Now, a rational zero is a nice number in the numerator and a nice number in the denominator. In other words, you have -1, -2, -3, -4, -5, and so forth, or 1, 2, 3, 4, 5, 6, 7, and so forth in both numerator and denominator. So it turns out that this particular function is written in descending power order. The first term has an exponent of 3, then we have an exponent of 2, then we have an understood exponent of 1, and then we have our constant term, which is degree 0, actually. We go from 3 to 1, 0, basically, in terms of exponents. And so it turns out that the numerator, what's above the fraction bar here, is a factor of the constant term. So we have nice numbers here for factors. Keep that in mind. And so one way to get 9 is just to take the number 1 and multiply it by 9. But we have to put plus or minuses there because we could have a negative in multiplication. We could have a negative number involved. The other way we can get 9 nicely is by writing it as 3 times 3. So we only have to write that 3 down once and then put a plus or minus. And we want these separated by commas. In the denominator, all the numbers in the denominator are factors of this leading coefficient, which is 4. It's the number out in front. And those numbers would be 1 times 4. And then we can also get 4 by taking 2 times 2. And we've got a 2 there. We have to only write it down once. We don't have to write the 2 down again. And we have plus or minuses in front of all these numbers as well. So these here will help us find our possible rational zeros. So we want every combination of a numerator in here, up here, with a denominator down here. So the way we go about this is I like to take every one of these numbers up here and put them over 1 first. So we would get 1 over 1 with the plus or minus out front, comma. We would then get 3 over 1 with a plus or minus out front. We would then get 9 over 1, which is 9, with a plus or minus out front. And this is a 3 over 1, which is just 3. I think I might have forgot to mention that. So that gives us these first 6 possibilities. So then after we put everything over 1, let's put all these numbers over 2. So we'd get 1 over 2, which is 1/2, with the plus or minus out front. We get 3 over 2, which is 3/2, with a plus or minus out front. We would get 9 over 2 with a plus or minus out front. So we'd get 9/2 here with the plus or minus out front. So lastly, we've put every number up here over 1 and 2. We need to put every one of these numbers over 4 now. So we would get 1/4 with the plus or minus out front. I had to go down here. And of course, we've got commas in between. We would then get 3 over 4, which is 3/4 with the plus or minus out front. And then we would get 9 over 4. 9 over 4 here with the plus or minus out front, separated by commas. And what we have here are, we've got 6 here, 6 here, and 6 here for a total of 18 possibilities. So where do we start? Well, I would start first by whatever's really, really easy to evaluate using synthetic division. I personally, if I didn't know what is a rational zero here, I would start with 1. So I think I started with 1 down here. So I took these coefficients, whoops, that put me back up here. I took these coefficients right here, 4, -16, +9, +9, 4, -16, 9, and 9. I wrote them here. I wrote them across here. I then said, well, 1's so very easy, +1's so very easy to work with. Let's check +1, and we can just write that as 1. So let's check 1 here. So we take this number in synthetic division, drop it straight down. We get 4 down here. Then we take this number up here, multiply it, which is 1, and multiply it times 4. 1 times 4 is 4, and that goes here. Then we add straight down. -16 plus 4 is -12. Then we take, and we want to focus on that -12 out of the corner of one eye, and we look up here and we have a 1, so we want to take 1 times -12, which is -12. And we add straight down. 9 plus -12 is -3. And then we go up here, get this 1 times this -3. 1 times -3 is -3. We add straight down. 9 minus 3 is 6. We're looking for a ZERO. So a ZERO is an x coordinate, which makes the y equal to 0. But we got 6. We did not get 0. So this number 1 is not a 0. We need to get the number 0 here for it to, if we got the number 0 here, then this one would be a ZERO. But it's not in this problem because we got a non-zero number, in this case 6. So 1 is not a ZERO. So we have to look further. Any questions on that synthetic division?
Can you show me the original problem?
So the original problem, it doesn't give us, you mean, are you looking for these coefficients right here?
Yeah.
4, -16, 9, and 9. 4, -16, 9, and 9. So that's what we have. That's what we have down here. 4, -16, 9, and 9. 4,
Oh, so
-16, 9, and 9.
they use that for the synthetic division part?
Yes. Yes.
Okay.
So that's how we always set up synthetic division. We take the coefficients of our polynomial, put them up here. We put, in this case, we're calling them ZEROs, and we're putting those candidates for ZEROs out here. We can only do one number at a time now. Does that make sense? And then we use synthetic division. Make sense?
Yeah, it's just the part from the beginning is confusing me. I get the synthetic division part. I just don't get the numbers you did at the top.
Well, they're the coefficients up here. It's the numbers in front of x to a power. So this is the number 4 that's in front here. And you have to have descending power order here. You have to have the largest exponent term, then the next, which is a 3. You have then the next largest, then the next largest, which is a 1 in this case, and then the constant. So you want just the numbers. Synthetic division is really nice because we don't have to write out the x's all the time. So we want 4. Then we have to have the negative sign if there is one. We want 4, then -16, then 9, and then we write down the constant as 9. Okay, I think you can see that when I did this one. We have 4. We have 4. That 4 comes from here, goes right there. That -16 comes from here, goes right there. This 9 out in front, this positive 9 out in front comes from there and goes right here. This 9 is the constant term, and that goes right here. Does that help?
Yes.
Okay. So that's what's going on.
Okay.
Did I answer all your questions about it? What we just did? Okay, good. So what I would recommend to you is to choose possible ZEROs that are simple to work with first before you choose the fractions. So you don't want to resort to the fractions unless you have to. So like I would now do +3, which you could say just 3, you could call just 3. So let's check 3. Let's check 3. So we copied all these down. We just looked at that. We put a 3 out here. Now we're checking 3. That's a possible 0. And so we bring the 4 straight down. We then take this 3 and multiply it times 4. 3 times 4 is 12. Add straight down. -16 plus 12 is -4. We then take this 3, multiply it by this -4. That gives us -12. And then we add straight down. 9 minus 12 is -3. We take this 3 and multiply it times this -3. +3 times -3 is negative. 3 times 3 is 9. So we get -9. Add straight down. 9 plus -9 is 0. So we just did find a 0, ZERO, because 3 here gave us the number 0 right here. So this is an x coordinate of an ordered pair, it's 3. This is a y coordinate, and it is the number 0. So remember, a 0 is an x coordinate, which we have here, that makes the y coordinate, this is the y coordinate, 0. So we have found our 0, and it is 3.
So in order for it to be a 0, The remainder would have to be 0 as well.
Exactly, because it's another name for this. This has so many names. This is also called the remainder. It's actually the y coordinate associated with an x coordinate of 3 on the graph. You know, it's the function f evaluated at 3. You know, it's got lots of names here. So this theory is pretty impressive, actually. Yeah. So any other questions? I'm loving the questions. It's keeping me awake after grading for a few hours in the middle of the night. So, yeah, I did take a nap for a couple hours, just slightly before I opened up the Teams meeting. So, any more questions so far? Because we're not done yet. We just found our first ZERO. Okay, so let's look down here and see what we can do. This is our ZERO. Now this, by the factor theorem, x minus a ZERO is a factor. So we want to factor. We want to keep factoring as much as possible as we go. So this is our ZERO. That means that x minus this 3, which is our ZERO, x minus 3 is a factor of our polynomial. X minus 3 is a factor. And so I put it in parentheses. And we are calling this polynomial f of x. So that's why I put the f of x right here. We can get another factor now by knowing that after we are going to ignore this now. The other factor we can get from looking at these numbers right here to the left of this vertical bar. So this number is the constant term. That would be -3. It's also C in the quadratic formula. This number right here is the coefficient of this is the constant term. If you're going backwards this way, you get constant term, then x squared. So this number would be the coefficient of x, so we would get -4x. And then this number is the coefficient of the x squared term. So we get 4x squared here. So let's write this down. So our other factor, we're going to write it in this direction because we write from left to right. So this is 4x squared in our other factor here, minus 4x minus 3. Any questions to this point? So we have to find our other two ZEROs. And when we find ZEROs, we're looking for the x's that make the y, and this is the y, the number 0. So we're going to take this quadratic factor and set it equal to 0 and use the quadratic formula to solve. When using the quadratic formula, you always want a quadratic factor set equal to 0. So let's do that now. So we're going to take this particular quadratic factor and let's look at the coefficients. They are 4, -4, and -3. 4, -4, and -3. So 4, -4, and -3. I wrote out the quadratic formula here so you could take a look. So let's just put the numbers in. X equals negative b. B is -4. Plus or minus square root b squared. B is -4, so I put -4 in parentheses and squared it. Minus 4 times a, which is 4, times c, which is -3. -3. All over 2 times a, which is 4. So I like to work with the square root first. So let's do that. This is -4 inside the square root squared. So that means we have 2 -4's multiplied together. So negative times negative is positive. 4 times 4 is 16. Then we have minus a minus, which is a plus. 4 times 4 is 16. Times 3 is 48. And if we add these two numbers together, we're going to get 64 here. The square root of 64 is 8. So that's nice there. So we won't have to work with the square root anymore in this problem. And let's take a look here. So x is equal to negative of a negative. That's a positive 4. Plus or minus this 8 up here divided by 2 times 4, which is 8. So let's write this out as 2 separate numbers. We'll write it out with the plus sign first. So 4 plus 8 over 8. 4 plus 8 over 8. Comma, let's write it with only the minus sign. 4 minus 8 over 8. 4 minus 8 over 8. And we just need to look at these and see if we can reduce them in any way, shape, or form. And let's do that. So we get, right here, we get 4 plus 8. 4 plus 8 is 12. 12 over 8. And over here, we get 4 minus 8, which is -4, over 8, which is 2 times 4. So we want to reduce these as much as possible and write these zeros in reduced form. So this 12 we can write as 4 times 3. 4 times 3 is 12. And this 8 we can write as 4 times 2. And the 4's will cancel. So when these 4's cancel, we're just left with 3 halves, comma. Over here, we can cancel these 4's. We have a negative left here. That negative sign is the same as -1. So we get -1 in the numerator. These 4's cancel. So we get -1 in the numerator over 2. We get -1 over 2 is -1/2. We get this. These are our other 2 zeros right here. 3 halves and -1/2. The quadratic formula will give you zeros, zeros. So we've got our other 2 zeros. So if we go back and we write out all our zeros in the answer box here, we have 3, comma, 3 halves, comma, -1/2. And that accounts for, if we look at this exponent, that tells us how many zeros we have. And we've accounted for all of them. Any questions? I still want to show you the graphing calculator and how to find zeros. You can't always find them on the graphing calculator, I'm going to say, but when you can, I want you to know how to do it. So
where did you get the 3?
Where did I get the 3? I just
Yes.
picked them. I picked them out of these possibilities here. Okay, so we got all these possibilities here. We could have any of these. There's 2, 4. We've got 2 possibilities here, +1 or -1, +1, we've got +1, or we could have also -1. We could have +3 or -3. We could have +9 or -9. We could have, so there are 6 here that we could have. There's 6 possibilities here that we could have. There are 6 possibilities here we could have. So what it's best to do is it's best to pick the positive integers first and check them. So we checked 1 first. We saw down here that 1 did not work. We got 6 down here, not the number 0. We then moved along and we picked this, or we looked at this 3. That's how I picked this number. So you want to avoid these fractions here with numbers in the denominator that are not 1. So you want to avoid those as long as possible and not work with those unless you absolutely have to, because fractions and synthetic division is more complicated to work with. Does that answer your question?
Yeah, that answered it. Thank you.
You're welcome. Yeah, it's a good thing you got your wheels you have your wheels turning today, right? Yeah, because this has got a lot going on in it. I mean, it shows that you it uses a lot of what you've learned this semester. So yeah. And so let's take a look at the graphing calculator. And like I said, it's not going to always work, but it's a good thing to try sometimes to save you some time. And so I want to make sure that I'm copying over this function because we want to definitely enter that into our calculators. If you've got your graphing calculator with you, you might want to work along and and I understand that some of you don't have it, and I understand why, so I'm good. So f of x equals 4x cubed minus 16x squared plus 9x plus 9. And if you need time to copy that down, just the function there that's up here, you want to copy this function down, and we want to put it in y1 of the calculator. That's what that is up there. So I'm going to go to the graphing calculator emulator right now, and I see it over here. And so let's see what we need to do. I'm going to go to y equals here, and I want to clear everything that's out that's in y1 and start fresh. So the first term I want to put in there is 4x cubed. So 4, the x is right here. It's the first character in this particular button or on this particular button. So I want to click on that for x. We want an exponent. So I want to use Mountain Peak. I just prefer to use Mountain Peak every time I want to raise to an exponent. It just, I don't have to remember where so many different special exponents are on the calculator. So I use this Mountain Peak right here. So I'm going to click on that. And we want an exponent of 3 this time. And then we're in the exponent, so I want to right arrow down on the normal line of writing. Minus 16. And then x. And this time we want a square on that. So I wanted to use the Mountain Peak and put a 2 there. And then right arrow out of that. Minus 16x squared. Plus 9x. And then plus 9. So we've got our function entered. Now what? Well, we want to go to window here. So we've got y equals, these are the graphing. This is really all graphing up here. So we want to go to window right here. That's negative 10 to 10, negative 10 to 10. So we actually want to go to window. That's good to know. So this means that on the x-axis of your graphing calculator, we are going from negative 10 to positive 10 on the x-axis. And then on the y-axis, we're going from negative 10 to positive 10 as well. So usually we work with that window. Above, and we don't really need that. You probably don't need to change that or do anything with that for this problem. But above window here, we have table set. We want table set up here. And it's hard to read. I realize that because we're working on the screen. So we want what's above window. And that's what we want is in this blue color. So we've got to click on this first and then window. And we want to set the table. So table start, I like to put that at 0. You probably could get away with it if you didn't. But let me see clear. I think that should clear that out. And I like to put in 0 there, especially when I'm looking for zeros. And then this is okay because this is going to tell us that we're going to go backwards 1 unit or forwards 1 unit for our x each time. So our x is going to start at 0 and we can go backwards 1. So 0 minus 1 is -1, -1 minus 1 is -2, and so forth. And going in this direction, we would go 0, 1, 2, 3, 4. We would add 1 each time. So we go backwards and subtract 1 each time. We go forwards, we add 1 each time. That's what this one is telling us. If you changed it to 5, you would be subtracting or adding 5 each time, and you would likely miss the zeros. So that's what we do. And lastly, we want a graph. It's right here, graph. And so we have an idea of what it looks like, and we've seen those polynomial functions before. And let's then go to table. You don't have to go to graph. I just pushed on it so you could see. And then the table up is above here. We want to actually go into the table of the calculator. So we want to do a second graph to get there. And now we're looking for a zero. Now remember, a zero is an x coordinate that makes the y coordinate equal to the number 0. So we want to look in the y column for the number 0. And you see it right there. But the zero is the x coordinate. So our zero is actually 3. It's the corresponding x coordinate, 3. So that's our zero. So you can scroll here and let me see how we would do that. If I wanted to, on this emulator, it's a little different, but if I could scroll there, and you will need to be in the x column to scroll. So you can scroll like this by using the up arrow key, or you could use the down arrow key and scroll like this. So any questions on that? And that's very helpful. And you can, whether you have a cubic function or quartic function, a 4th degree function, you can still look for zeros the same way. You're not necessarily going to find them because you could have a 0 that is a fraction where the denominator is not 1, and you're not going to pick that up here. So it does work sometimes, but it doesn't work all the time to look at the graphing calculator. So any questions on this particular problem? So that's one of the 3 topics we want to do on zeros of polynomials. I'm going to check that off. And let's go on. Let's take a look at this problem. So last problem we worked on, we looked at rational zeros, which are rational numbers are an integer over an integer. Here, we're not looking at rational zeros this time. We're looking at irrational zeros, which can have a square root in them. So let's take a look at this one. Use the rational zeros theorem to find all zeros of a polynomial, irrational zeros. And this time we've already looked at the different ways to get your zeros. You possibly can get it on a graphing calculator, get the starting 0 or zeros on a graphing calculator, or you can create a list of possible rational zeros and work work through them to get your ZERO to get started. So I'm just going to work this one and just go through the process more so than creating a list of possible rational zeros. And I'm not going to look at the calculator here because I showed you already. So what you could do. So here's our function, h of x equals 7x cubed plus 19x squared. And I'm checking when I read this to see if it's all the powers are there. So we have 7x cubed, we have the cube term plus 19x squared, we have the square term plus 3 times x to the understood 1. We've got the first degree term minus 5 is the degree 0 term because it's a constant. And what do we want to do? We're told that this function below has at least one rational zero. Use this fact to find all zeros of the function. So we want to find all the zeros. So let's construct a list of possible rational zeros. And the way we do that is each possible numerator is a factor of this constant term 5. So that the only ways to get 5 using nice numbers is 1 times 5 with the plus or minus out front. The possible denominators are factors of this leading coefficient here, which is 7. That would be 1 and 7. 1 times 7, which I put down 1 here and 7 here and put the plus or minuses out front. And then we can make a list of all possible combinations. So I take everything over 1 first. So this would be 1 over 1, which is 1 with the plus or minus out front. This would be 5 over 1, which is 5 with the plus or minus out front. And now let's take everything up here over 7. 1 over 7 is 1/7 with the plus or minus out in front. And then 5 over 7 is 5/7 with the plus or minus out front. So
it would always be the last number over the first number?
yes, yes,
Okay.
yes. That's right. As long as you've got this in descending power order, and I can't guarantee that. Okay? This polynomial has to be written in descending power order.
So
Okay,
you always
so it's
start out
always
with
like
plus.
gonna be the. Go ahead, Matthew.
Oh, my bad. You can go. Oh,
So it's always gonna be the number that has the greater coefficient. I mean exponent, and then the number that has a no exponent, basically.
Yes,
Or
yes,
no
it
X.
understood 0. Yes. It's always that.
All right, thank you.
You're welcome. Matthew, what about you?
so you always start out with plus or minus 1 to start the thing.
Well, I'm not going to do it in this problem because, yeah, that's the way I would recommend it for you guys. But I don't have a lot of time here, and every time I do one of these, it takes quite a bit of time. So I'm just going to go straight to negative 5/7, 5 over 7 here. Okay, but yes, that's the way I would do it if I were you. I just don't want to eat up a lot of class time by checking too many possibilities.
Mm-hmm.
Does that make sense?
Yes, a lot bit better.
Okay. So I know that this is a 0. So let's just use this in the interest of time and go through synthetic division. I think it's important that you see me do a fraction anyway, because it is a little more complicated than, and the numbers that we've seen before that we have put out here. So we have negative 5/7 here. What numbers do we have across the top? 7, 19, 7, 19, right here. And the last two numbers are 3 and negative 5. 3 and negative 5. You want to make sure you're keeping your signs here. So let's work through the synthetic division table. This one, we always just drop it straight down. So we drop the 7 straight down and just get 7 here. Then we're going to multiply. We're going to take this -5/7 here, and I wrote it down here, -5/7 times this 7. So we're going to take this times this. So -5/7 goes here, and this 7 times 7 here. If you notice, these 7s cancel out. We've got a 7 in the numerator and a 7 in the denominator. They cancel. We're just left with a -5. That -5 goes here. Then we add 19 plus a -5 is 14. So then what do? We now keep our one eye, or part of an eye on the 14. We take our -5/7 and multiply it times this 14. -5/7 times 14. 14 divided by 7 is 2. 14 divided by 7 is 2, and we have negative up here. So maybe we should do it this way first. We have our final answer is going to be negative. 14 divided by 7 is 2, and this is 5, so we're going to have 5 over 2. So it's going to be -5 over 2. No, wait, 14 divided by 7, what am I saying? It's positive, it is 2 itself. 14 divided by 7 is 2. Long night. 14 divided by 7, I'm checking it on my calculator, is positive 2. So this right here is positive 2. Times this 5. 2 times 5 is 10. And then it has a negative sign in front. So that's -10. And then add straight down. 3 plus a -10 is 3 minus 10, that would be -7. And then we're going to take this -5/7 and multiply it by this -7 here. Negative times negative is a positive. These 7s cancel, and we're left with just a 5. 5. And then we add straight down and get 0. So we get the number 0. So that means this -5/7 is a zero. So now we want to factor. So we have a 0 here, and we know that x minus a 0 is a factor. So in our case, we have x minus this -5/7. 5/7. That's a factor. But minus a minus is a plus. So it goes in as a here's the factor. It's actually x. This will be plus here. X plus 5/7 is a factor. Our other factor comes from, we ignore this 0 now. It comes from here. If we go backwards from this vertical bar, we have our constant. This is our x term. This is our x squared term. So now what do we have? Our other factor is right here. As long as we put in have the appropriate signs, and we assume that they're positive unless we have a negative in front of a number. So we have 7x squared in this, starting this factor in parentheses, plus 14x minus 7. That's our quadratic factor. Now, what I did personally is I looked at this. You don't necessarily have to do this. You could just set this quadratic factor equal to 0 and then use the quadratic formula. Or you could look and say, hey, I see there's a factor of 7 in each term and factor that out. So I took a 7 out front. So if I take a 7, this 7 went out front, we're left with x squared inside, plus 14 is 7 times 2. The 7 went out front, the 2 stays inside here, and then it's times x. And then this one is minus. This is 7 here is really 7 times 1. The 7 went out front, the 1 stays here. So what I did is I took this, circled this in purple, and I set this equal to 0. You're welcome to use these in the quadratic formula. I was just making it a little simpler with smaller numbers. I prefer to do that. So these numbers now for the quadratic formula are A is this understood leading coefficient, which is 1. This B here is 2, B equals 2, and C is -1 for the quadratic formula. So let's take a look. Let's go to the next page here. And I'm just checking my numbers. It's a stretch. We get 1, 2, and -1. 1, 1, 2, and -1. Good. So I set that quadratic factor equal to 0. Wrote down what A is 1, B is 2, C is -1. Here's the quadratic formula. We get x equals -b, which is, and that negative, b is 2. Plus or minus, square root, b is 2 squared. Minus 4 times a, which is 1, times c, which is -1. All over 2 times a, which is 1. Let's work with the square root. 2 squared means we have 2 2's multiplied together, so 2 times 2 is 4. Minus a minus is a plus. 4 times 1 is 4. So we have plus 4. 4 plus 4 is 8. We get square root of 8. 8 we can write as 4 times 2. So we get square root of 4 times square root of 2. Square root of 4 is 2. So we write that as a 2 outside. This square root of 2 we can't do anything with. So we leave it as square root of 2. So let's rewrite this now. -2, -2, plus or minus. All of this turned out to be 2 square root of 2. 2 square root of 2 over 2 times 1, which is just 2. In this last step here, I factored a 2 out of here and out of here. You could just ignore this minus sign and ask yourself, what are you going to do? What would you do if you had a plus sign there? Just a plus sign there. So for a second, you can ignore that minus sign, but we have to think about it again shortly. And just what would you factor out of the top here? So you want to kind of ignore that minus sign for a moment, and you have a 2 here and a 2 here. So let's factor that 2 out. So we're going to factor the 2 out way out front. When we take this 2 right here, it goes way out front. We're left with the negative. That negative is really -1. Plus or minus, this 2 went out front. And what we have left inside is square root of 2. All over this 2. 2 divided by 2 is 1. And 1 times what's left is what's left. So these are our other 2 zeros. Our other 2 zeros are -1 plus or minus square root of 2. We want the 0 where we get using just the plus sign, and we want the 0 that we get just using the minus sign. So if we go back, I wrote those down and see what the problem wants us to do. So in this problem, we want, what are we trying to find? I've got so involved in the problem, I didn't remember. Use this fact to find all zeros. So they're not asking for factors here, they're asking for zeros. So our first 0 that we verified was -5/7. We verified it here, and we got 0, the number 0 here. And then we want to separate by commas. The next one, we're going to get the 0 here using just the plus sign. So that's -1 plus square root of 2. Negative 1 plus square root of 2, comma. And then we will get negative 1 minus the square root of 2. The only thing that changes is this plus changes to a minus over here. Any questions on this particular problem? Yeah, there are a lot of, these do have some definite steps in here. So we're working with irrational zeros, and I want to look at another one for you. So this is another question in the same topic that we just did. But what makes this one so different? If we look at our polynomial here, we have x to the 4th. We have a 4th degree polynomial here. We haven't seen a 4th degree polynomial yet. And why this theory is so very important is because it allows us to factor cubics and quartics and so forth. So let's do that. So I'm looking here at our function. We've got 4, 3, 2, understood 1, and constant. We have all of our terms. So we do not have to use any zero placeholders. Remember, if we skip a term here, we have to use a placeholder. Say if we didn't have the 2nd degree term, and we put in 5 in our synthetic division table and then 27, we would then have to put in a 0 for this one. We would have to put in a 0 for the x squared term if there was no x squared term listed. So you want to make sure you're using zero placeholders, and that is also true for the constant. If you have no constant, you still want to put a 0. You would then want to put a 0 here. So what do we want to do here? We can use a graphing calculator, or you can create a list of possible rational zeros. Either way. I used the graphing calculator and found that 2 and negative 7 are zeros. I got that from the graphing calculator table. And we can go through that if you want as well in the detail. But I think that it works the same way, and maybe it would be a good thing to do. So let me just copy this down. So we've got, here is our function 5x to the 4th plus 27x cubed. 5x to the 4th plus 27x cubed minus 61x squared. Minus 61x squared minus 33x plus 14. So graphing calculators, TI graphing calculators, are in wide use throughout the country and probably even the world. I just haven't had much experience with the world part of it outside the United States. But I've taught in Ohio, I have taught in Arizona, I have taught in Arkansas, and they were in use in all those places. So, and I've heard from my friends around the country and going to various trainings and stuff. They're in wide use. So if you transfer to another school, chances, and you take any more math related courses, even if they're not in math, but in another discipline, you would likely be using a TI graphing calculator. And so it's important to understand, to get some understanding of how they work. So I am going to go to the emulator here. I'm going to go back into y equals, and I'm going to clear out what's there. Sometimes you can change what's there, but I find that more, I'm not as confident personally when I do that. I like to re-enter it. So 5x to the 4th. Mountain Peak 4. Go and use the right arrow to get out of the exponent. Plus 27x, and that is Mountain Peak 3. Mountain Peak, and then the number 3. And then I'm going to right arrow out of that. So 27x cubed minus 61x Mountain Peak 2 minus 61 minus 61x squared. And then I'm going to write out arrow out of this. So I'd like to take my time with this. Minus 33x and then plus 14. And I'm going to go to the, I'm now going to go to the table. So that's above the graph key. So I have to use the second key first and then graph. And we're looking in the Y column for the number 0. Remember, a 0, Z-E-R-O, is an X coordinate that makes the Y equal to the number 0. So I already see one right here. We have a 0 in the Y column. So that means that the corresponding X coordinate is the Z-E-R-O, and that would be 2. So this guy right here. And if you go this direction, the numbers are going to get pretty big. So let's go backwards the other way. And let's see, we're going to look. I have to move when I use the up arrow key, I'm required to be in the X column. So looking in the Y column, we're looking in the Y column for a number 0. Let's see if we find one. And there in the Y column, we have the number 0. So that means that this X, which is -7, is the Z-E-R-O. So let's go back to our document here. And we found, we saw in the calculator 2 and -7 are zeros, Z-E-R-Os. So what we're going to do is we're going to do synthetic division. I personally would always pick a positive number over a negative number first, because that means we have to work with the negative number less. So let's work with the 2 first. So we put a 2 outside here. And then across the top here in our synthetic division table, we have a 5 and then a 27. So we have 5 and 27. And then a -61. -61, then a -33, and then a +14. And let's just do our synthetic division. We drop this number straight down and get 5 down here. Multiply 2 times 5, 10. 27 plus 10, 37. 2 times 37 turns out to be 74. When we add -61 plus 74, we get 13. 2 times 13 is 26. Adding these two numbers together, we get -7. 2 times -7 is -14. And when we add these two numbers together, 14 plus -14, we get the number 0. So that is what we wanted to get, because based upon what we saw in the table of the calculator. So now after we do that, what we do now is really, let's do this. I want to just ignore this. Let's just ignore this now. Let's ignore what's beyond the vertical bar. We just want to work with the numbers that are before that vertical bar now. That's why I circled these 4 numbers. So we ignore this now. So let's go ahead and we are going to do synthetic division again. How are we going to do synthetic division again? Well, we're going to use these numbers, but instead of being below here, they are going to actually appear We're going to make another synthetic division table because we have another 0, zero, and we are going to use these numbers. We're going to copy the 5 down, the 37 down, the 13 down, and the -7 down. And this time we're going to use our other zero, the -7. And so let's do that. So this number gets dropped straight down, 5. Then we take this -7 and multiply it by this 5 to get -35. We add straight down. 37 minus 35 is 2. We then take -7 times 2 and get -14. 13 plus -14 is -1. We then take -7 times -1. Negative times a negative is a positive. 7 times 1 is 7. Add straight down. -7 plus 7 is 0. So this means this 2 is a zero because we got a remainder of 0 over here. This -7 is a zero because we got a remainder of 0 over here. So we started with a 4th degree. One of our zeros, this 2 here, took it down to a 3rd degree. So here we're working with a 4th degree polynomial. Here we're working with a 3rd degree polynomial. This -7 is taking this 3rd degree polynomial down to a quadratic polynomial, you could say. So that's how this works. So now this took it down to this 2 took it down to we started with a 4th degree polynomial, we went down to a 3rd degree polynomial, then we went down to these numbers, which are the coefficients of a 2nd degree polynomial, which is a quadratic. So we want to now label this like this, just like we have before. This vertical bar on this side is the quotient. So this is C is -1. And I didn't put, so C is -1, B, I didn't put in the X here, is 2X. And then that B would be just 2. So this is -1 plus 2X plus 5X squared. Didn't put in the X's here. So I was trying to show you that these numbers are all you need for the quadratic formula. You don't need to put in the X's if you do not wish to do so. So this C is -1, this B is 2, this A is 5. So it's A, B, C, as long as you know for sure you have a quadratic at that point. But the way to really know that is to go backwards. Constant, X term, X squared term. So now we know what our A, B, and C are. We can use the quadratic formula, and we get X equals -B. Negative B is 2. Plus or minus square root B, which B is 2, squared, minus 4 times A is 5, times C is -1, all over 2 times A, which is 5. And we're just going to work with this. Let's work with the square root. So this is 2 2's multiplied together, so that would be 2 times 2, which is 4. This is minus a minus, which is a plus. 4 times 5 is 20, times 1 is 20, still 20. Add these together, we get 24. 24 we can break down into 4 times 6. Square root of 4 is 2. Square root of 6 we can't do anything with. It breaks down into 2 times 3. No way we can take any of those, either one of those two numbers out. So we're just left with 2 square root of 6 here. So going down here, we get -2 plus or minus 2 root 6, 2 square root of 6. So we get -2 plus or minus 2 square root of 6 from here. All over 2 times 5, which is 10. We can factor a 2 out of the numerator. Factor a 2 out of the numerator here. So this 2 goes out front. What's left? This negative sign's left inside. That is really -1 plus or minus. This 2 is, we're factoring it out front. So this 2 is going out front here. And then what's left inside is square root of 6. 10, the 2's have it. So 10, we want to think how we can write it as 2 times something. It's 2 times 5. 2 divided by 2 cancels. It's actually cancels because it's equal to the number 1 times what's left is just what's left, which is right here. So what's left is -1 plus or minus square root of 6 over 5. So now we want to see what the problem is asking for. At this point, are they asking for ZEROs or are they asking for factors? They could be asking for either one. So they're asking for find all zeros, ZEROs. So these guys down here are, there's 2 of them. Each one of them is a ZERO. So the first one, -1, just using the plus sign, -1 plus square root of 6 over 5. -1 plus square root of 6 over 5. -1 plus square root of 6 over 5. And then there's the one with the minus sign in the middle here as well. So those are our 1, 2, 3, 4 zeros, which since this is a 4th degree polynomial, we need to account for 4 zeros, and we did. 1, 2, 3, 4. Any questions on this particular topic? So we did 2 questions in the same topic, but I wanted to show you a cubic one and also a 4th degree polynomial, which we call a quartic. We're not going to do this one. I didn't want to, so close to the end of the semester, and I don't think doing more of these necessarily is helpful. I think I just want you to understand the process. So we are now going to go to the, let me check the one off we just did. We are now going to go to using a given 0 to write a polynomial as a product of linear factors, complex zeros. So what we do is we do this exactly the same as we did the last problem, except we're asked to find a product of linear factors. The only additional step we have to do above and beyond what we did in the last problem is we just need to know that x minus each ZERO is a factor, and write those factors down correctly. And that's the only real difference between the topic we just did and this topic. The last topic asked for zeros, ZEROs. This one's asking for us to write the polynomial as a product of linear factors. And we're just going to use the factor theorem, which is right down here, which says x minus a ZERO is a factor. So let's take a look at this one. Now this problem is particularly nice because they give us a 0 to start. For the polynomial below, 1 is a ZERO. Here's our polynomial. We've got 3rd degree term, 2nd degree term. This has an understood 1 on it, 1st degree term, and constant in descending power order, which is what we really like to have. Makes working the problem simpler. And so we want to express f of x, this function, as a product of linear factors. So this 3 here tells us, this highest power here tells us we have to account for this many zeros, zeros. That means we have to have 3 zeros. Well, if we have 3 zeros, x minus each one of those zeros is a factor, which means we're going to have 3 factors as well. So let's find those. So I just copied f of x, this function down here exactly so we can see it closer, and we're not going to, I don't have to keep scrolling up so much. And we are also told here 1 is a 0. So that's nice because we have a cubic that being given that 0, zero of 1 will help us will then get it down to a quadratic, which is very nice. We're going to use that 1, 0 of 1, and it's going to take us down to a quadratic. So the coefficients across the top. So we're told that 1 is a 0. Let's put that out in front. That goes out in front because what out in front are possible zeros, always. You can consider them to be possible 0. Whatever number's out here is always a possible zero. And the numbers across inside are 1, -7, 24, and -18. And let's do the synthetic division. We're going to drop this 1 straight down. Then we're going to take this 1 and multiply it times that 1 to get this 1. 1 times 1 is 1. -7 plus 1 is -6. So we added straight down. We take this 1 times this -6, and that gives us 1 times -6 is just -6. 24 minus 6 is 18. 1 times 18 is 18. -18 plus 18 is 0. The number 0. That proves that 1 is indeed a zero. So now we went from a 3rd degree when we did this division. This is really division because you can consider it to be division. We're talking about adding a negative and so forth. So it's just easier to do it with adding, and that's what we do. And that's how all of this has been designed. So I have the vertical bar here, and going backwards, this is now we've gone from a 3rd degree down to a 2nd degree, which these are coefficients of a x squared. This is a coefficient of over here of x squared. So x squared means we have a degree 2 polynomial. We've got constant. This is the coefficient of x. This is the coefficient of x squared. So we have a quadratic factor here, really. And that's what we want to write now. So our other factor, we know what are our factors. X minus a 0 is a factor. So x minus our given 0 of 1. X minus 1 is a factor. X minus 1. So I'm writing our polynomial. We're trying to factor it now. Our quadratic factor from here is, this is 1 times x squared, which is x squared, minus 6x plus this 18 right here. That's our quadratic factor. We're going to copy this factor down, and we want this x minus 1, and we want to set this factor equal to 0, and we want to solve for x. So that means we're going to use the quadratic formula. So x equals -b. So this is x equals -b. b is -6. Plus or minus square root b, -6 in parentheses, and then we want to square it. -4 times a. A is right here, it's 1. Times c, which is right here, which is 18. And that's all over 2 a, and our a is 1. So let's clean up this. Let's work with the square root. This is negative 6 squared. In other words, that is negative 6 times negative 6, which is a positive 36. So I have it over here as positive 36 inside the square root. So over in the blue here. And then minus 4 times 18. So 2 times 18 is 36. And then 36 plus 36 is 72, but we have a minus out in front. So it'd be minus 72. So 36 minus 72 is negative 36. And this square root of a negative number, let me write it in for you. So if we take the square root of this right here, let me kind of go over here, maybe down here a little bit just to show you. We have this, the square root of this negative sign we can replace with a negative 1. So let's do that. Let's see if I can get this off. I want to get that blue gone away there. I'm not sure how to do that. Maybe I go back in here. That will allow me to do that? Maybe. I think I'm just going to take it away. So I better make sure I do everything the right way here. So this is the square root of negative. This negative sign is negative 1. So we're really talking about the square root. I'm going to make of. That's better. Okay. Negative sign is negative 1. I'm just going to put it in parentheses. And then we have this 36. Kind of funny that I'm writing with my finger, but the ink smears. It doesn't, it would, it's just my, okay, so that's what we have. Now, what is the square root of negative 1? So we have the square root of negative 1 and the square root of negative 1. That's the imaginary unit, I. That's the imaginary unit, I. So this guy right here, the square root of negative 1, that comes out, that part comes out as just I out front. Square root of 36 is 6. Put the 6 in front of the I. So we just get 6i. We just get 6i. We want to take the entire square root and replace it by 6i. So we get, close this off, we get that x is equal to negative of a negative, which is a positive 6, plus or minus 6i, all over 2 times 1, which is 2. And we once again want to look to see if we can factor something out, and we can factor a 2 out from this 6 and also from this 6. So let's take a 2 out front. If we take a 2 out front here, this 6 is 2 times 3. The 2 went out front, the 3 stays. Plus or minus. And then this 6 is also 2 times 3. The 2 goes out front, the 3 stays. And there's this imaginary unit of I there. All over 2. So 2 divided by 2 is 1 times what's left is what's left. These right here are the other 2 zeros. So we have 2 other zeros. We've got the 1 with the plus sign only. So if we cover up that minus sign, we've got a 0 of 3 plus 3i there. Now remember, these are zeros. By the factor theorem, x minus each zero is a factor. So when we're factoring, we always put parentheses around our factors. These outside set of parentheses are around the factors. Because our zeros, each one, the 3 plus 3i, that is a zero, but it has two terms in it. So we need, when our zero has two terms in it, we want to make sure we're putting that zero, that zero, we want to make sure we're putting parentheses around that zero as well when it has two terms. So x minus this 0 here is a factor. So x minus this 0 right here, 3 plus 3i, is a factor. You want to put a set of parentheses around the factor and a set of parentheses around the zero. It wouldn't make sense. We wouldn't need to put parentheses around the 1. It wouldn't change what we've got there. And then we want to do x minus our other 0 as well. And that would be with the minus sign, 3 minus 3i, 3 minus 3i. It's a two-term zero, so we want to make sure we're putting parentheses around it. Any questions on the parentheses or anything else on this problem? So we're going to do another one in this particular, another question, same topic. I want to make sure you understand how to, I don't want to just do a third degree when there's a possibility of you seeing a fourth degree. For the polynomial below, 2 is a 0 of multiplicity 2. That means that 0 appears twice, which means we have to use it twice when we're doing our synthetic divisions. So since we have a 0 of multiplicity 2, we can use that 2 once to take this 4 down, to take this quartic, this fourth degree polynomial down to a third degree or cubic polynomial. We can then use that same 0 a second time because it's of multiplicity 2 to take it from a cubic down to a quadratic. And that's where we're headed with this. So we're told that we've got a 0 of multiplicity 2. If you notice, we've got a degree, we've got a power of 4 here. I don't see a power of 3 at all. We have to use a 0 placeholder. So we're going to start off with the coefficient of the fourth degree, this fourth degree term, which is an understood 1. Then we want a third degree term. We don't have one that we see, so we put a 0 placeholder. We have to go 4, 3, 2, 1, and then constant. So we have our fourth degree term here. That understood coefficient in front is 1. We do not have a visible third degree term, and that so we need to put a 0 placeholder in for it. For our, then we go 4, 3, 2. That coefficient is -4. That goes here. Then we go to the first degree term. That coefficient is -16. That goes here. And then our constant term goes last. So let's do the synthetic division. So imagine that this right here is just a line. So this right here, see how careful I can go over this? Okay, that's just a line. Think of that as just a line right now. So we're going to do, and ignore this 2 down here for now. We're going to do our synthetic division like we're used to. This 1 comes straight down. This 1 comes straight down. Then we take the 2 times this 1. 2 times 1 is 2. We add straight down. 0 plus 2 is 2. Take this 2 times this 2 to get this 4. -4 plus 4 is 0. we take this 2 times this 0. 2 times 0 is 0. Negative 16 plus 0 is negative 16. This 2 times this negative 16, it's negative. 2 times 16 is 32. When we add 32 plus negative 32, we get 0. And we need to get 0 because in the problem, they told us that 2 is a 0, Z-E-R-O, of multiplicity 2. So we've used the 2. We've only used one of the 2s so far to take this quartic down to a cubic. So we got 0 here, which is what we needed. Now we're going to ignore it, so I crossed it out. And we're only going to work with these coefficients because we no longer have a 4th degree polynomial, which has 1, 2, 3, 4, plus another one because we had to put in the 0 placeholder. A 4th degree polynomial has 5 coefficients. 1, 2, 3, 4, 5. Now, that one division, if you will, took us down to a 3rd degree polynomial. Is going to take us, yeah, that took us down to a 3rd degree polynomial, which means we have 1, 2, 3, 4 numbers up here. So that's what we're looking at here. So we want to use the number 2 again because it's a 0 of multiplicity 2. So now you could write this, you could we could get the purple here and just kind of make this look like look like a division symbol, but we don't need to, as long as we know that's what it is. So we're going to take this number, drop it straight down, that 1 goes there. 2 times 1 is 2, that goes right there. 2 plus 2 is 4. And then we take 2 times 4, which is 8. 0 plus 8 is 8. 2 times 8 is 16. Negative 16 plus 16 is the number 0, which we expected to get because we were told that we've got a 0 that 2 is a 0 of multiplicity 2. So now, what do? We put our vertical bar in just like we usually do. We went from a 4th degree to a 3rd degree, and now we went from a 3rd degree to a 2nd degree, which is a quadratic. So this is A, B, and C, these numbers in the quadratic formula. And going backwards from this vertical bar, this is our C. Our C is 8. Our B is 4. And our A is 1. And we know how to write the quadratic factor now. So what we have is, by the factor theorem, x minus each ZERO is a factor. We have 2 as a ZERO of multiplicity 2. So x minus 2 is a factor, and since we have another 2, x minus another 2 is a factor. Just like this. X minus 2 times x minus 2. And then our other factor over here is a quadratic factor. It's 1 times x squared, which is x squared, plus 4x, plus 8. 8. So we need to set this equal to 0, use the quadratic formula, and figure out where we're at. So let's look at that. Here are our A, B, and C for the quadratic formula. So x equals negative b, which b is 4. So that would be negative 4 plus or minus square root b. That's 4 squared minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. So let's clean this up. -4 plus or minus square root 4 squared, that's 4 times 4, which is 16, minus 4 times 8 is 32, times 1 is still 32. So we get 16 minus 32 there, all over 2 times 1, which is 2. So working with the square root, 16 minus 32 is -16. This negative sign can be replaced by -1. Square root of -1 is I. And then square root of 16 is 4. So that's where the 4i comes from. So negative, we get down here, we get -4 plus or minus 4i all over 2. Let's factor out a 2 from the numerator. We could factor out a 4, but it's not going to do us any good to do so because we want to cancel this 2. We're really after canceling this 2 in the denominator. So let's just factor out a 2 from the numerator because that's all we need to do. If we take a 2 out of this numerator, we're left with this negative sign inside. 4 is 2 times 2. This one of the 2's went out, the other 2 stays. Plus or minus. We want to take, we've got the plus or minus 4i. 4 is 2 times 2. 1, 2 went out, goes out here. The other 2 stays. And then we need to copy over this I, the imaginary unit. Divide it by 2. So this is, we're going to write the plus 1 with the plus sign only, -2 plus 2i, right here. And then we're going to write the one with the minus sign only, -2 minus 2i, right here. Those are our other 2 zeros. So our other 2 zeros are -2 plus 2i and -2 minus 2i. Going back here, we've got to write our other 2 factors. So x minus each zero is a factor. So x minus the zero, the first zero that I wrote down is -2 plus 2i. Since this has 2 terms, we need to put parentheses around it. And then we have, this is a special multiplication symbol, if you will. So we've got this here. I didn't want to make it look like x because there's an x right here, so I put a little line there. So we have times this other factor, x minus times x minus this other 0. X minus this other 0, which is -2 minus 2i. And this has 2 terms, so we have put it in parentheses. Any questions on this particular topic? I'm going to just check that one off. Let's see what time it is, and I'm going to come back up there for just to see how you all are doing. Wow. So we're okay. Okay, so we have 4 minutes left. Does anybody have any questions about what we covered today or about the class in general? So the final exam, let me talk a bit about the final because this is important. There are 2 parts to the comprehensive final. The first part and the part that's going to impact your grade the most is the ALEX portion. It's going to be like other ALEX tests. In that there's 17 questions. And you will upload your written work to Canvas for the first 7 of those questions. So it's going to be like the test 1, test 2, and test 3 in that sense. So that's not really different. Because we're using ALEX and everyone else teaching college algebra is using MyLab Math, the assessment questions are in MyLab Math. So we had to come up with a way for me to give you all assessment questions, those same 4 assessment questions, because we, in order to be get accreditation at NWAC, we have to have assessment questions. So there are 4 assessment questions. I asked the ALEX folks if I could put those somehow in ALEX, and they said no, there's no way to do that. And I was bummed. Because I've been trying to give them I give them advice from time to time about what I need, and they asked me to do that, and I'm like, that's what I really need. I need the ability to write my own questions sometimes, or at least put them in a form, or some kind of form. But we don't have that yet, and I don't know if they're going to do that. So the only place to put them was and there are 4 assessment questions, is to put those 4 assessment questions in Canvas using a practice quiz. So they do count for 2% of your grade, but there's 4 of those assessment questions. They are a little bit different style than you're used to seeing. They're worth a small amount of your grade, 2% only, and chances are they're multiple choice. So chances are you're going to get some of them right. The odds are on your side that you're going to get, since they each have 4 possible answers, the odds are on your side that you're going to get at least one of them correct. So, and I looked at them, and I think, that 3 of them look like they're doable for most of the students in this class. I'm not sure about the 4th one. If you look at it right, you might be able to get it. So I wouldn't stress too much about it. It's just a requirement that I need to fulfill as my faculty duty I've got to fill out an Excel spreadsheet and put scores for each student in all of 4 of my ALEX classes in there. And I just want to make you aware of that. So if you could put in the chat that something about I'm aware of the Canvas quiz. That's what I want you to put in the chat today for your participation credit. Just, I'm aware of the Canvas quiz, and that will get you participation. If you could just type that in really fast, I would, even if you put CAN for Canvas, I don't care. Just wanted to make sure you're aware of that. And then feel free to leave, and you're welcome to stick around and ask questions if you would like.
This Canvas quiz, does it open the same day as the final? Like, do we take the final comprehensive final and ALEC, and then we do this? Or does it open the week before, or how is it going to work?
No, it opens when you take your final. So the way you would do it is you would do the ALEX part of the final is worth 18% of the course grade. So you want to take the ALEX part first, and then you want to upload your written work to Canvas for the first 7 questions. So you will then be in Canvas. So once you're in Canvas, you will then click on quizzes and take the assessment quiz. And we'll talk more about that because we've got 2 classes next week too. Does that make sense?
Yeah, that makes sense. Okay, thank you.
You're welcome. Good question. Yeah, you too. Anybody else have any questions?
Yeah, Ms. Bear, I have a question. For our previous tests that we have taken, are we able to, once it's graded, look back and see like which ones were the questions that we got wrong?
Yes, it is we can talk about that too. And I want to mention that I do drop the lowest test score out of the first 3 test scores. I cannot drop the comprehensive final. But when I grade your test 3s, I will then also drop your lowest test score of the first 3 tests. But you can look back. So there are a couple of because of the proctoring and so forth, and we don't typically test like this, but we're in a pandemic situation. So one place you can look is I make comments in Canvas about, sometimes, not all the time because I have a lot of tests to grade, but sometimes I make comments there about why I took off points. And the other places you can look is you can look in ALEX in the grade book to see what you got, but you can go to assignments in Alex, and you should be able to review your old test as well.
Okay, I'm gonna hop in there later today and see if I am able to look into it. That's what I was curious about. If I could look at the specific questions and see, you know, like what I got wrong. So I'll try it later today, and if I have some trouble, I'll try to email you.
Could you let me know whether you are able to do that? Because that's what I've been, what I'm making it, from what I know, that's what you should be able to do. But I don't know because can't see the student side. You know what I'm saying? I can't see the assignment side.
Yeah, sure thing. Yeah, I'll definitely give it a try, and then I will shoot you an email and let you know.
That's so great. Thank you so much.
Thank you, Ms. Bear. Have a great day.
You too. Bye.
See you. Bye-bye.